Let's take a look at chemistry in action. Here we have 3 balloons, and each of them is exposed to a candle flame. But they don't all respond the same way. Why do you think this is? What makes the 3 balloons different from each other? As you may have guessed, the 3 balloons each contain different gases: helium, hydrogen, or a mix of hydrogen and oxygen. Let's take a look at the 3 different balloons and see what happens to each one. We'll start with the balloon filled with helium gas. Daniel lights a candle. The candle is tied to the end of a long stick so that he can bring the flame close to the balloon from a safe distance. What will happen when the candle flame touches the balloon? Now let's see what happens. The balloon pops open with a loud sound, and the candle flame is extinguished. Let's take a closer look at this in slow motion. The balloon skin peels back starting from the point of contact with the flame due to surface tension. The helium gas rushing out of the balloon extinguishes the candle flame. Now let's consider a balloon filled with hydrogen gas. Let's see what happens when we touch the flame to the blue hydrogen-filled balloon. What do you think will happen? This time, when the flame touches the balloon pops open with a very loud sound, the flame is blown out, and the gas ignites, producing a fireball. Let's review the process in slow motion. The balloon skin peels back due to surface tension, and the hydrogen gas rushing out of the balloon extinguishes the candle flame. As the hydrogen gas molecules rush out of the balloon, they react with oxygen gas molecules in the surrounding air, producing a growing fireball. The reaction between hydrogen and oxygen gas molecules continues as diffusion allows the hydrogen and oxygen molecules to come into contact with each other until all of the hydrogen from the balloon has been consumed. Next, let's think about what happens when the balloon contains a mixture of hydrogen and oxygen gases in a 2-to-1 ratio. How do you expect this balloon to be different from the balloon containing 100% hydrogen? Remember that power is change in energy per unit time. This time, when the flame touches the balloon pops open with a very loud and explosive sound, and an intense fireball forms immediately. But in this one, the candle is still lit. Let's look at this one in even slower motion. As the gas rushes out of the balloon, it does blow out the candle. But because the balloon is filled with pre-mixed hydrogen and oxygen gas molecules, they immediately react and produce a bright flame as the balloon skin begins to peel back. The reaction is extremely fast and explosive, producing the intense fireball that we observed. The flame from the hydrogen and oxygen reaction reignites the candle. If we compare the explosions of the hydrogen-only balloon and the hydrogen-oxygen balloon, you can see that the hydrogen-oxygen balloon explodes faster and produces a brighter flame. Let's compare these 2 explosions in terms of the power of the explosion and the total amount of energy released. It turns out that even though the hydrogen-oxygen balloon explosion looks bigger, it actually doesn't produce as much energy as the hydrogen-only balloon. That's because there are more hydrogen molecules in the hydrogen-only balloon. They react with oxygen from the surrounding air. What the oxygen-hydrogen balloon does produce is more power. Power is energy divided by time, and the reaction in the oxygen-hydrogen balloon happens more quickly because the gases are already mixed.